40. That is what we want to see now. And what will be the value of 25 times 40 will be equal to 1000 joule. And that is the value of the kinetic energy for question number 1. Question number 2. Question number 2 says, how long will it take a 60 kilogram man to climb a height of 22 meters if he expended energy at the rate of 0.25 kilowatts? How long? I've told you that how long in physics means time. So we are given the mass to be equal to 60 kilograms. We are also given the height to be equal to 22 meters. Then we are given the power, because the unit of power is watts. But in this case, we are given in kilowatts. It's 0.25 kilowatts. We are told to calculate the time. In this case, we are calling from power is equal to work over time. Power is work over time, and work is mgh over time. In this case, we are going to have P to be equal to M, which is 60. G is our number associated to gravity, which is 10. Our height is 22. Everything over time. But we have been given the value for power, which is 0.25. But in this case, we are given in kilowatts. To convert kilowatts to watts, we are going to multiply it by 1000. Because kilo means 1000. Kilo is 1000. Kilo means 1000. Okay? Whatever you are having, multiply by 1000. That's what we are having. Everything over 1. In this case now, we are going to have our time to be equal to, from what we are having here now, is going to be 60 times 10 times 22, all divided by 4.25 times 1000. Without wasting time, we can quickly use our mathematical instruments to figure out the value. 60 times 10 times 22 will give us 13,200. Then if we quickly look at the value of the denominator, 0.25 divided by 1 times 1000 rather, times 1000, we have 250. Then all together, we are going to have divided by 250. The answer is 52.8 seconds. Question number 3. The question says, a spring of force constant 1500 Newton per meter is acted upon by a constant force of 75 Newton. Calculate the potential energy stored in the spring. The force constant we are given is the K, which is equal to 1500 Newton per meter. We are given the force itself. The force is 75 Newton. We have to calculate the potential energy stored in the spring. From Hooke's law says we have F varies as E. F is equal to KE, and your K to be equal to F over E. Okay? So in this case, potential energy is equal to half Fe. This can also be equal to half Ke squared for a spring. Okay? Let's make our E, the strength of the formula here, we are going to have F over K. Substitute E to where we have E. Half times F times E. Instead of having E, we have F over K. Then that is what we are going to use to calculate what we are told to calculate, which is the potential energy stored in the spring. So which is equal to half our F, which is the force, 75. Then that's our head. Then another half, that's another 75 divided by K. Our K is 150. 150. So from there, we can try to 75. In this case, 75 goes in 150. We are going to have 2. 75 here, 1. In 150, we have 2. Okay? And what you are going to have is going to be 75 over 4. 1 times 75 times 1 is 75. Everything divided by 4. And at the same time, we are going to have 75 divided by 4. We are going to have 18.75 joule. And that is the work done in the spring, the potential energy in the spring. That's question number 3. For question number 4, the question says a body at rest is accelerated at the rate of 0.5 meter per second squared for 2.5 seconds under a constant force of 80 Newton. The work done on the body is, let's take it one by one. Acceleration is 0.5 meter per second squared, that's for the body. The time is 2.5 seconds, that's for the time. Then we are given a force, 80 Newton. Then the question says, what will be the work done on the body? You remember that the work done will be equal to force times distance. Okay? In this case, we have the force, no distance. But we are given some other parameters. What are we going to do? We are going to recall that x is equal to ut plus half at squared. This is one of the equations of motion. Okay? But the question says a body at rest means initial velocity is equal to what? 0. Then we are going to have s will be equal to half at squared. This is going to be half. Acceleration has been given 4.5. Time has been given 2.5 squared. Let's quickly analyze this. We are going to have 2.5. Now we give us 6.25. If we multiply together with 0.5, we are going to have 3.125 all divided by 2. And if we try to do that, we are going to have 1.5625. And that is the distance. So together now, the work done will be equal to force, which is 80, times 1.5625. And when you multiply with what we are having by 80 now, we are going to have 125 joule. 125 joule. And that is the answer to question number 4. Question number 5. The question says a force varying linearly with the distance acts on a body as shown in the figure above. The work done on the body by the force during the first 10 meters of motion is, let's consider this diagram. This is the diagram we are referring to. We have to calculate the work done on the body, the work done on this body for the first 10 meters. This is the time. okay, this is the distance. This is the force. This is the distance. And once you have been given force and distance, automatically we are looking for something relating to work done. Okay? To calculate the work done on this figure, the figure, if you look at this shape, it represents something, and that is a trapezium. The area of the trapezium represents the work done. That is the brain behind that. Represent the work done. And what is the area of the trapezium? Is half into A plus B times height, which is equal to half into your A is for the fourth side, your B is for the second side. The fourth side, the second side. Okay? So for the first side, between 0 and 20 is 20. Between 10 and 0 is 10. Then the height will now be, because if you try to draw this diagram appropriately like this, you are going to have, so this side will represent this. This side will represent this. This side will represent this. So this is our height. This is your A, this is your B. So the height will now be between 10 and 0, which is 10 times 10. So we are going to have half. This is 30 times 10. 2 here, 1, 2 in 30, 15. So we are going to have 15 times 10. And the value of 15 times 10 will give you the work done for a body undergo this motion. So 15 times 10, what is going to be the value of 15 times 10? That is what we are going to have now, and that will give us 150 joule. Remember, the unit of work is joule. 150 joule. That's the solution to question number 5. Let's quickly consider question number 6. Question number 6 says a pump lifts water into an overhead tank at high load 18 meter at the rate of 7 kg per second. Calculate the power of the pump. Power is equal to work over time. And power is equal to, this is work over time. This can be equal to force times distance over time. If you look at this question, we are given 18 meter, and at the same time, we are given 7 kg per second. The 18 meter there is the distance. The 7 kg per second, let me write 7 kg per second. But if you look at this formula, we have kilogram per second. We are still going to split this. Your force is mass, okay, A times X over time. Then we are having kilogram per second together, okay, which is equal to power is equal to, let's take it to the motion of a body under gravity. We are going to have M times G times H over T. Instead of having acceleration, I want to have G. Instead of having distance, I want to have H for height. Then we are going to have this and this together because we are given kilogram per second. Kilogram is mass, seconds is time. We have taken the two quantities together, okay, which is equal to 7 for this. Then your number G is 10. We are given height 18, which is for power. So we are going to multiply 7 by 10 by 18. Will give us the power, and that's what we are having there for question number 6. So if you are to get 7 times 10 times 18. 7 times 10 will be 70. Then we are going to have 70 times 18. Then we are going to have 1260 watts. 1260 watts. And that is the answer to question number 6. Question number 7. Question number 7 says a pump engine lifts 200 kilograms of water to a height of 120 meters in 20 seconds. What is the power of the engine? What is the power of the engine? It's still the same thing, but it's just a different way of doing it. Power is still equal to mgh over t. mgh is your work over time, which is equal to, we are given the mass to be 200, then we are given the height to be 120, everything divided by 20. And that's all. That's what we are to do there. And then we have this one, cancel this. We have 2, that's 6. Okay? So what I have here is 200 times 10 times 6. And it's going to be 200 times 60. Okay? And 200 times 60, if we try to go through that, we are going to have 200 times 60. We are going to have 12,000 watts. We are looking for power. Watts. So the power is 12,000. And if you like, you can take it to 1, 2, 3, 4. 1.2 times 10 is to the power 4 watts.